Part C.3, Golden Ratio. In order to calculate the Fibonacci numbers, it is very interesting. We need to use the golden ratio. It is a very interesting property. So let's look at that. Here, some information related to the golden ratio. First, how to define golden ratio. This part describes how to define golden ratio, but later, so we will look at the details. Then this part, we use the geometry property to show some really good property of Fibonacci numbers. So look at the way we use the Fibonacci numbers. First, 1, 1, okay? F0 equals 0, F1 equals 1, F2 also equal to 1, okay? Here, we do not use F0, we start with F1, right? So you can see we draw a small square with side 1. Side, okay? The length of the side equal to 1. Then F2 also 1, so we put them together. After that, third square with side 2. The size of the side, the length of the side equal to 2. So you can see two little square, you put them together, then the total length just match the length of the third square. So you can see we can align in a perfect way, right? In that way, then the fourth square, the side 3 equals 2 plus 1, so we can also get another perfect alignment. Okay? Similarly, next one, 5, perfect alignment, right? So in that way, we can grow that rectangle. It's a rectangle shape. We can grow bigger in a perfect alignment way. All right, so that's the first step. Second step, we can draw a nice spiral from there. All right, we start from the innermost little square and draw arc using its side length as the radius. Okay, the first one. All right, then the second, another arc using the so let me see. Because it's too small, hard to see it. Anyway, so you can get the idea. Then the next arc, quarter arc, right? Quarter circle. The length of the arc, that's the quarter circle. You keep doing that. The radius of the arc is bigger and bigger, but two different arcs, two adjacent arcs, they join in a perfect way. With different radius, but they join in a perfect way. So then finally, you get a good-looking spiral. Okay? So you can see, so that's the many interesting properties of Fibonacci numbers. Then this Mona Lisa picture, people also can discover some relationship about that. So whatever, All right, so you can see this tells us Fibonacci numbers, golden ratio, they are closely related. Here, we need to see why they are closely related. First, let's look at the definition of the golden ratio. First, we draw one line segment. Okay, one line segment. All right. After that, we divide it somewhere in the middle, somewhere. But when we divide it into two, smaller line segments with length A and B, we want to make some ratio, special ratio condition. So what's the special ratio condition we need? Yeah. Longer line segment, its length A over the shorter line segment length B, that ratio should be the whole line segment A plus B over the longer line segment A. That sounds reasonable, right? So this kind of, first, this arrangement looks reasonable. Yeah. All right. Then, if we require this ratio property, what should be the ratio? What should be the ratio of that bigger line segment over smaller line segment? We want to find that. Yeah. So here it looks like we only have one equation, but we have two variables, variable A and variable B. So based on our equation knowledge, it is not enough to find the values A and B using just the one equation, right? Because we need at least two equations to find the value. But here we don't need to find values A and value of B, right? We don't need to find their values. We only need to find the ratio. Ratio. That's different from the values. Yeah. In order to find the ratio, let us simplify the right-hand side a little bit. 1 plus B over A. After this simplification, we can introduce a new variable represent this ratio, X. We make the ratio X to be this A over B ratio. Okay. After that, then here, right-hand side, B over A, that's just 1 over X, reciprocal of X. So you can see our original equation, we can use one variable to represent the original equation. X equals 1 plus 1 over X. Okay. Yeah, just one variable. All right, yeah. Then after we do the simplification, X squared equals X plus 1. It is a simple quadratic equation, and we can solve it easily, right? Yeah. Here, let us solve the simple quadratic equation. We have the quadratic formula, so let us recall the quadratic formula for this general quadratic equation. A not equal to 0, so it's a true quadratic equation. We have this formula, okay? Two possible values of X, okay? X equals numerator minus B plus minus root of B squared minus 4AC, then denominator 2A. That is the famous quadratic formula. We just plug in ABC numbers for our quadratic equation. Here we can get two possible X values, 1 plus minus root 5 over 2. But if we go back to our original ratio definition, line segment A over B, line segment A over B must be positive, right? Yeah. It does not make sense, negative ratio A over B. So for that background, we can drop the negative option. We only keep the positive option. Yeah. So we make x equals 1 plus root 5 over 2. If we calculate its approximate value, it is just 1.618. So this is the famous value of the golden ratio. Yep. Precise expression of the golden ratio, 1 plus root 5 over 2. Usually, we use the Greek letter phi to represent it. Yeah. It's numerical approximation because it is an irrational number. You know irrational number, the meaning, right? Irrational. Irrational number. Okay? So not rational number. Okay? You know rational number, right? Rational number can be represented as a fraction. Okay? Integer numerator over integer denominator. Non-zero denominator, integer. Okay? Yeah. That's the rational number. Irrational number, the real number that cannot be represented as the rational number. That's simple. Okay? So this is an irrational number. Yeah, approximation. Yeah. Like this. Yeah. All right, so after that, then the magic formula for the Fibonacci numbers. Yeah. Here, why it is so magic, so we will see the power of math. Yeah. We can derive it. We can derive this formula. So later, we will spend a lot of time in our part D. We will derive this formula. And also we prove it. Yeah. Prove and derive, two different ways to get this formula. Yeah. All right, I'll give you the formula first. F sub n, the Fibonacci number, yeah, equals 1 over root 5 times parenthesis phi to the nth minus negative 1 to the nth over phi to the nth. That expression, Fibonacci number expression. Here, phi equals 1 plus root 5 over 2. You can see why I call it a magic number, because we know the Fibonacci number is an integer, but the right-hand side, we use phi, golden ratio, that is irrational number. We use an expression of irrational number after we do subtraction, yeah. Then we need to multiply 1 over root 5, then we get an integer. That integer is a Fibonacci number. That's the magic. Usually it is very hard for people to imagine why it can happen. But in our video, part D, we will see why it is true. Yeah. All right. So next, the question. How can you connect the Fibonacci numbers to the golden ratio? That's the topic in our video, part D. Yeah. All right. So we finish part C.